Okay, so as part A of the question, it asks us to predict the splitting patterns of each in the proton NMR spectrum of this molecule 1,3-dioxane. So that would mean predicting the splitting patterns of each carbon, which would be 2, 4, 5 and 6. And if we start with carbon 2, it would, as it has no hydrogens on the adjacent molecules, it would be a singlet because of the no adjacent hydrogens, which are the protons in this instance. And then because using the n+1 rule, you'd do 0 + 1, which would then give you the singlet. Then next we'll move on to carbon 4 and 6, which would both be considered the same hydrogen environment, and so would produce one peak altogether, as they are both next to an oxygen and another CH2 molecule. So carbon 6 and 4, they would both be triplets because adjacent to each molecule they have 2 hydrogens. So using the n+1 rule, as 2 adjacent hydrogens. And then using the n+1 rule, you do 2 + 1, which would then give you the 3 splits to give you the triplet altogether. And then finally we've got carbon 5, which, if you look at it, on this it is adjacent to 2 different carbons which both have 2 hydrogens on, so it would be a multiplet. As 4 adjacent. Hydrogens. And then using the n+1 rule again, it would be split into 5 splits, as there is 4, and then 4 + 1 is 5. So then that would give us 5 splits, which would then equal a multiplet.